A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians, welcome back to another video. Thanks to everyone's feedback on the last video about the whole Indian controversy. I'm going to post an update soon. All the insights were quite interesting, even though we got a lot of hate comments, which was to be expected. So an update on that matter soon, and thanks to everyone who supported the channel financially and just by watching the video and leaving their comment down there below. Many people also bought on stemmerch.eu to compensate for the money that basically the scammers got off of me. And yeah, thank you very much. Now I have a lot of work to do. And yeah, update soon, and now we are going to dive into the main video. Video sponsored by Print, by the way. More information at the end of the video. Check it out, wonderful website. Now, currently the new year has started, school year, and I'm teaching the 7th grade yet again. And in 7th grade we cover fractions and decimals and also repeating decimals, periodic ones. And I showed them how to convert periodic decimals into fractions with filling out nines and the denominator and all the other way around. And there, as an example, I was showing them 5 divided by 7. So 5 divided by 7 is a number between 0 and 1. Okay, this is cool. So we definitely have something 0 dot. And now we are going to fill all the decimal places here. Now, something divided by 7 has a very, very cool behavior, and I'm going to talk about this in a different video, a completely dedicated video on the numbers 1 divided by 7, 2 divided by 7, and so on. It has a very epic cyclic behavior, and you can check out the Fuchs's video, linked down there in the description. He already covered it in a little math song, which is pretty cool. Now, what about the decimal expansion? I mean, okay, 7 fits 7 times into 50, then we get a remainder of 1, fits 1 time into here, remainder of 3, fits 4 times into there, remainder of 2, 2 times remainder of 6, then this gives us 8, remainder of 4. This means we can fit it 5 times into here with a remainder of 5, giving us this epic number as a decimal expansion. 0.714285, repeating up until infinity. Now there's also a cool way to turn repeating decimals, if you have this right here given, into a fraction once again. What to do is you take the repeating part, so 714,285, and you are going to fill the denominator with all nines, okay? With the number of digits that you have in the numerator. Now this right here is the algorithm. And I was showing this to my students, and they were looking like, bruh, seriously, how can this number right here, this thick individual, is it just me or is this number looking kind of thick? Thanks, Danny. How can this number be equal to 5 divided by 7? This seems unreal. How can you even multiply something by 7 and get 999,999 out on the other side? And the lesson ended with me giving them homework. Namely, I wanted them to use the divisibility rules from last year that we covered in the hopes that they are going to be enough to actually get from this fraction, by cancelling out in numerator and denominator the prime factorization, back to 5 divided by 7. I'm going to teach them tomorrow, and I haven't done this for myself yet. This is just a fun little exercise, and hence the video. What we are going to do is we are going to try to cancel this fraction or reduce this fraction such that we land at 5 divided by 7. And I hope it's not going to end up terribly wrong with some kind of prime factor of 5,177. I don't know if that's prime, but I hope we don't get any kind of prime factors like this in this little fraction right here. So try it out for yourself. Maybe you can figure it out, and I'm going to try my best to actually reduce this fraction as much as possible. That's an improvised session, by the way. I haven't done it for myself yet, so that's going to be an interesting one. And let's dive right in. So if you want to find out the prime factorization of a number, we are just going to use the easiest method that you can use mentally, namely the prime number sieve. Meaning we are going to start with the smallest prime number and see if one of the two is divisible by the number 2 at first. No, they are not even numbers, so that doesn't work. Now next comes the number 3. I mean, I can already see that the denominator is divisible by 3 because we have all 9s in there, and the number is divisible by 3 if the digit sum is divisible by 3. Same thing up here, so 7 plus 1 is 8, then this gives us 12, 14, then 22, 27. 27 is actually divisible by 9, same as the denominator, meaning both numbers are actually divisible by 9, or to put it into prime factorization terms, 3 squared. So what we are going to do is we are going to divide by 9 at first. Now dividing by 9 in the denominator is rather easy. We are just going to get 111,111. But what about the numerator? This already starts out pretty freaking epic. Okay, divided by 9. So how I would do it in class with my students is I would tell them to look for a number which is really close to a nicely divisible by 9 number. Now, I mean, 720,000 is nicely divisible by 9 and it's pretty close to 740,000 und ein paar zerquetschte, as you would say in German. So yeah, we are going to go with 720,000, but we also need to see what we need to subtract to get back to our original number. Now, what we need is we need 5,715. Okay, thus far, that's good. Meaning, dividing 720,000 by 9 is going to give us 80,000. And then we get negative 5,715. What's the next nice number which is divisible by 9 next to 5,715? 5,400 definitely, so negative 5,400, but how much is missing to get to this number? 315, I suppose, divided by 9. Now what we're going to get is 80,000 minus 5,400 divided by 9 is going to give us 600. And then 315 by 9 is going to give us, okay, 360 would be 40 times, but we need 45 less. So negative 5 is going to give us 35. So negative 35, giving us overall, and I hope that's correct, 365. Okay. Yeah, this is what we got right now. So we have reduced the fraction already by a factor of none, giving us 79,365 over 111,111. Okay, let's start with the prime number c again. It's not divisible by 2, obviously. It wasn't before, so it won't be now. Now what about 3 once again? Let's go with 3 again. Denominator is divisible by 3, so 1 plus 1 plus 1 is 3, 1 plus 1 plus 1 is 3, 6 overall is the digit sum divisible by 3. So since we can reduce the fraction completely, we also know that the numerator must also be divisible by 3. So we get 16, then 19, 25 and 30, meaning we are going to divide it by 3 once again. Oh, I was being stupid. The original number was divisible by 27. Yeah, obviously. Yeah, it was divisible by 27, and I suppose this holds for all powers of 3, that if the digit sum of a number is divisible by the power of 3, then the original number is also going to be divisible by the power of 3. Okay, let's start off with the numerator. So 79,365, and if it wasn't clear from the context already, we are not just going to take the numerator and the denominator divided by 5 and 7 respectively and just cancel out the common factor. That wouldn't be any fun. We are going to suppose that we don't know that it's divisible by 5 or 7, or we just don't want to use it right here in the prime factorization. We want to get back to 5 over 7 by using just elementary means, without assuming that we know that it's 5 and 7 that we're looking for. Now, what is nice and close? 81,000 or 78,000. 78,000 plus 1,365 divided by 3. Okay, this right here is going to give us 26, I suppose. 26,000 plus. Okay, this is 1,200, so 400 plus 155 divided by 3 is 150, gives us 50 once again. 155. Give me a sec. 150. Did we go wrong somewhere? 65. 1,365. Oh yeah, 65, not 55. I'm terribly sorry. I was thinking, did we do something wrong here? But obviously this was divisible by 3. So yeah, I just did something mentally wrong. So we need 400 definitely, and we also need 165 is 50 is 18. No, 55 plus 55. Giving us overall 26,455. Okay, what about 111,111 divided by 3? Nicely next to it is, there are so many numbers, nicely next to it, but let's go with 120,000 divided by 3, but minus what? Minus what? So what we need is, we need mental arithmetic, subtraction. What do we need? We definitely need a 9 in some way, but then we are filling this up. So we need a 9, 9, 9, 9. Is that correct? Yeah. 9. Okay, this right here is going to give us 40,000 minus, and dividing this is 3,333. Okay, giving us overall, is that correct? 9,999. I think I'm doing so. Give me a second, I'm going to go the other round. Subtraction sometimes is a bit harder. Divided by 3. How much is missing? Missing is 90,000, so we still need plus 21,000 plus 111. Okay, so this gives us 30,000 plus, and then 7,000 plus 111 divided by 3. What is that? 30 definitely, 21 missing, 737. Oh, that's an interesting number. Okay, that was definitely easier than subtraction. I think I did something wrong up there. 37,037. That is quite interesting. So what we got right now is, after dividing everything, we are going to end up with 5/7 being equal to 26,455 divided by 37037. Okay, so here at this point we can already see that the denominator is definitely divisible by 5, and we would have been able to see this earlier at the first step, but never mind. Let us move on. Is it divisible by 3? Once again, no, it's not. We get 10 here and 10 here, 20 not divisible by 3. Can't be divisible by 4 because it's not divisible by 2. By 5 we don't care about that, and also not 7. 6 is not divisible by that. Then it can't be divisible by 8, it can't be divisible by 9. Then by 10 it also can't be divisible. Next, 11. 11, a number is divisible by 11 if its alternating digit sum is divisible by 11 or 0. Let us start with the top. 2 minus 6 is -4 plus 4 is, yeah. Okay, we're going to get 0, so meaning this number is divisible by 11, and same thing here, 3 minus 7, and then we're going to get plus 3. No, minus 3 plus 7, yeah, those are going to cancel out. Meaning, division by 11 is going to give us, okay, 26,445 divided by 11. Okay, 22,000 is nicely next to it. 4,455 is missing, meaning that's 4,400 plus 55. Divided by 11. That decomposed very nicely, giving us 2,000 plus 400 plus 5, giving us overall 2,405. Okay, this is already pretty good. That's a really small number. Now what about this number? That's probably something very easy that I can see right now. But let us go through the process once again. So 33,000 is nicely next to it, plus then we need 4,000 37. So this means we still need 3,300. Meaning what is missing is 737. 737 is the same as saying we have 770 minus 33. Yeah, okay. That's a nice decomposition. This is way easier than dividing by 3 or the like, in my opinion. Okay, so what we are going to get is, this is 3,000 plus, and then we get 300 plus 70 minus 3. So this makes 67, so 3,367. Okay, meaning 5 over 7 is the same as 2,405 divided by 3,367. Okay, now next up. Is it divisible by 11 again? So we checked all the numbers before that. Is it divisible by 11 again? 2 minus 4 is negative 2 plus, no, not divisible by 11. Okay, next number 12 doesn't work. Next number 13. I have no idea what the divisibility rule for 13 is, but we have a way of deriving it. Let me show you how you can see if a number is divisible by 7. I derived it before. You can find the link down there in the description. So what we are going to do is we are going to say that a number, for example 207, is the same as 200 plus 7. Meaning we are going to say that this right here is some number b, and this right here is some number which we multiplied by 10, and we're going to call it a. So 20 is our a, so 10 times 20 is going to give us 200. Meaning what we are going to say is we are going to turn this into something that's divisible by 7, at least one part of it, to get ourselves a divisibility rule. I think it was like that. What we're going to do is we're going to add 20b to it, so that's the same as 10a plus 21b minus 20b. Okay, so we're going to add and subtract 20b. Meaning this right here is equal to, so we get 2 times 10 here, giving us a common factor of 10 with this part. 10 times a minus 2b plus 21b. And now you can see 21b is divisible by 7, and the original number is only divisible by 7 if this part, a minus 2b, is also going to be divisible by 7. This gives us an algorithm for divisibility by 7. Namely, what you are going to do is you are going to take the last digit off, b, you are going to double it, and then you are going to subtract it from the rest that is still left after covering the last digit up, 20. Okay, giving us 7 times 2 is 14, 20 minus 14 is going to give us 6, not divisible by 7, hence the original number isn't either. And this right here, this algorithm that I showed in this one video, is actually sufficient for each and every number that you can find out there. Use this algorithm and you can find out each and every divisibility rule if you didn't know about already. Okay, this is really cool. That's a really cool fact. Let's do it for 13. We are going to say that, okay, let's use 207 yet again. Once again, this right here is 200 plus 7. Let's say this right here is 10a plus some b. Okay, now we are going to turn this into something that is divisible by 13. We are at 13 right now, meaning we are going to give 10a. So 12 would do the trick probably, or we could add, no, I'm going to add 25b to it. Okay, so, and we are going to subtract it, so negative 25b plus 26b. This right here is divisible by 13. This is good. And why did I choose 25 here? Because 5 is a common factor. Meaning this right here is going to be 5 times 2a minus 5b. Meaning, a number is divisible by 13 if you take the last digit, you are going to take it times 5, then you are going to subtract the last digit multiplied by 5 from the first, or the things which are still left, multiplied by 2. Okay, let us go with a number which is divisible by 13 and let's see if it works. 169, nice. It's definitely divisible by 13, it's 13 squared. Meaning what we're going to do is we're going to take last number times 5, giving us 45. And then we are going to subtract this from 16 but doubled, 32. 32 minus 45 is going to give us negative 13, which is divisible by 13. This works out very nicely. Oh, I love to derive divisibility rules from scratch. You just can't explain this in class. No one is going to get it, at least not in high school. So that means what we are going to do is we are going to see if these are divisible by 13 in the first place. So let's go with 2405. This right here is going to give us, okay, we are going to take last digit times 5, meaning this right here is going to give us 25. Then we are going to subtract this from 240 times 2 is going to give us 480. 480 minus 25 is going to give us 455. Still not certain if it's divisible by 13. 13, what's next to it? 390 is definitely next to it. Then we have 65 left, and 65 is 5 times 13. Yeah, this works out. This number is divisible by 13, hence the other number down here must be 2. I mean, you can try it out. It should be. Now let us divide 2405 by 13. What's next to it? 2600 minus 195 divided by 13. This is going to give us 200. Okay, that's a nice number. Minus, okay, 195, 130, then we get 65 left. This is 5, so 10, 15 minus 15 is going to give us 185. Ah yeah, cool. We are done already. And what about 3,367 divided by 13? What's next to it is 2,600, for example, plus, okay, then we are going to get 767 left. What's next to it? 13, 26, 39, 52, 65 yet again. So 650 plus 117. 117. 117, so 65 times 2 is 130. So this would be 10 times, so this is 9 times. So this right here is going to give us, okay, so plus 9, I don't want to lose this one. This right here would be 550, and then we are going to get 2,600 divided by 13, not 9, oh goodness. This would be 200. So this is 259. Okay, so 5 divided by 7 is the same as 189 divided by 259. And for these small numbers, I'm just going to go through the rest of the numbers that we haven't covered already and see if they could be divisible by it. Okay, so 13. All the even numbers really don't matter because those are not divisible by 2. Meaning 13, then 14 doesn't count. 15 definitely not. We don't want to have 5 here. No, 185. Yeah, okay, that was weird. I was already wondering because the numerator must be divisible by 5. Okay, 15 doesn't matter. 16 doesn't matter. 17, 170. No, doesn't work. 18 doesn't matter. 19, 190 also doesn't work. 20. 21, no, it's not divisible by 3 anymore. 22, not divisible by 2. 23. 23, 230, and then we're going to get 207 minus, no, doesn't work either. 24, no, 25 doesn't matter, 26 doesn't matter, 27, no, not divisible by 3 anymore, 28, 29, okay, 29 could be interesting. Let's go with the denominator, 29, 290 minus 29, no, doesn't work either. 30 doesn't matter, 31. 31 would be 310. No, or let's go with this one up here. This is easier. Times 5 is going to give out 155. 186. No, doesn't work. 31, 32 doesn't matter. 33, 33. No, doesn't work either. 34, no. 35 doesn't matter to us. 36 doesn't work. 37. Okay, 37. 37 times 5. Hey, we got a winner! 37. 185 divided by 37 is equal to 5, if I'm not mistaken. Yeah, obviously, we need to get back to 5. And what about 295 divided by 37? This should work out too. It should be 7 in normal case. 7 times 30 is 210. 7 times 7 is 49. Yes, works out nicely. And we are done. We have found out all the prime factors. Namely, what we got up here. This boy that we got right here is the same as, okay, we got 3 to the 3rd power times, and then we got 5 times. After that, what we got is 11 times, and then we get 13 times 37. Same spiel down here. 3 cubed times 7 times 11 times 13 times 37. And I thank you guys for watching. That was a long adventure, but I really like this one. That was a very cool mental arithmetic exercise, and I hope you did enjoy what you have seen today. And if you want to learn more about divisibility rules, number theory, and all the things that we did today, and even more than that, then I invite you to try out the contents of today's sponsor Brilliant, who are kind enough to sponsor yet another video here on this channel. Gosh. The Ghost Blackboard is going berserk yet again. Yeah, I'm always glad when Brilliant decides to sponsor a video here on this channel, because the more videos they sponsor here on this channel, the more I can get the word out to the world how much of a great website it actually is. And with the help of Brilliant, you can learn new topics in STEM, be it mathematics, physics, computer science, chemistry, etc. Doesn't matter what you're looking for, pretty quickly and in a very intuitive fashion at that. Intuitive in the sense that they are going to provide you with nearly 70 interactive courses in all the topics STEM that I just told you about. Interactive means that you are going to be able to go through the exercises with the help of visuals, graphics, and just things that you can play around with. Graphs, triangles, just taking the corners, grabbing them, and trying to see how the interior angles of a triangle are going to act. Or if it's about number theory, how all of the divisibility trees are going to work out when you want to take a look at the prime factorization and the like. And even more than that is available on their website. Next to these interactive courses, they also got community-created Wikipedia pages, as well as daily challenges, and when it comes to the holidays, they also have special events going on their website. So Christmas is pretty much around the corner, so if you're still looking for someone who needs a perfect Christmas present, then why not give them a premium subscription for Brilliant today? And if this feels like it's something for you, if I piqued your interest, then definitely make sure to check out the link at the top of the description, brilliant.org/flammy. With it, you're going to get free access to a big portion of Brilliant already, so you can try it out. Take a look at the content firsthand, but more importantly, the first 200 people to actually make use of the link get 20% off an annual premium subscription, which is a really great deal considering how much content they just have available on the website already. And they are always putting new content out on a monthly basis, which is just so great. You're going to get so much buck for your money, no, bang for your buck, this is what you say. You're never going to run out of content virtually ever on their website. So definitely make sure to check it out and support the channel this way. If you enjoyed this video, then also subscribe to the channel, subscribe to Flammy's Wood, my woodworking channel, and don't forget to support the channel by checking out Patreon, Teespring, and whatever I have available. Links down there in the description. And up until next video, I wish you guys a flammable day. Ciao, and please stay safe. And don't forget to train your brain by doing some mental arithmetic. Hey, that's kind of thick.